Good afternoon, everyone, and welcome to today's sponsored ABC webinar, Life Cycle Assessment for Biogas, Current Status, New Tool Trends, and Future Potential. My name is Caroline P., and I will be facilitating this webinar. Before we begin, I want to give a really big thank you to P6 Technologies for sponsoring today's webinar. Their sponsorship, along with all of the other webinar sponsorships we get throughout the year, support ABC's programs directly, so thank you so much to P6 Technologies. Before we start with the content, which we'll get to in just a minute, I just want to go over a few things here, a little bit of housekeeping. You should be able to see my slides. Right now it says quick notes at the top. If you're hearing echoes or your sound quality is bad, you can change the audio options in the GoToWebinar toolbar, which will be right on the right side of your screen. If you're still having any trouble, send the organizers a message using the question section on the toolbar, and don't worry, we are recording this webinar. The recording and the slides will be available to you after the webinar. We send them out to all registrants, and they'll also be on the ABC website. If you have any questions, ask those throughout the webinar in that panel, in that questions pod. We will be handling questions at the end of the webinar, but you can ask them at any time. And so with that, I'm going to thank you all for joining us, and I'm going to pass it off to Heather Dietzig with ABC to lead you through our presentation and introduce you to the rest of our speakers today. Heather, please take it away.
Good afternoon, everybody, and thanks for joining us on the webinar today. It's definitely a topic that is front of mind for a lot of those of us in the industry, so we appreciate you guys joining us. I'm going to just give a short intro with respect to ABC's role in this conversation and then hand it off to Bernie for intro. But ABC has been working with others in the industry for over a year to develop a carbon accounting methodology specific to biogas based on GREET and to essentially fill the holes and correct assumptions that are detrimental to the industry. The connection is as that rolls out toward the end of this year, where we actually have tools and inputs for people to run their own LCAs under this new methodology, it ties in potentially really well with what the P6 team is going to talk about today. And so it's a really natural fit for ABC and the industry, but also for that very particular effort and scope of work that ABC has been doing over the last year and a half. So we're really excited to help draw those connections for you guys today. So I'm going to go ahead and toss it over to Bernie, and he'll get you acquainted with the team.
Hi, good afternoon, everyone. And I'm coming to you from Lake Romo, which is in Lapland, Finland. I'm 18 miles off the Russian border. We're up here fishing, and you'd say, well, why, Bernie, would you do this? Because when I met Joe and Kira down in Savannah, I was blown away, fully just blown away, and said, I told them, I said, you do this webinar, and I promise you, no matter where I'm at or what I'm doing, I'll come on and make this introduction because this is such an important and amazing topic. And their software, they finally had to make me leave their booth, because I kept playing with the computer, and then the time was up. So I'm really excited about today's event. The P6 is an innovative software company. They're really something else. This life cycle analysis, as Heather said, and these assessments are so important, and be able to run them quickly and what we've got going on currently. So, and that's why Heather said, Bernie, I need to jump in here also because again, this is so important. Again, I really think you're going to gain insight into where the companies are with this journey, understand the drivers of the LCA software, and really to extract the value from the LCAs, leveraging the integrated in the solution that they're going to provide. So at this point, I'm going to let Joel have some slides up. They'll tell you who they are. I wanted you to know from the ABC's viewpoint and from my viewpoint just how important this was, how impressed I was with Joe and Kira and their software, and again, how important I think this is that we get this message out. So at that point, I'm going to go ahead and hand it off to Joe, and I'll slink back into the woods of Lapland here, or the tundra of Lapland, I should say.
Thank you, Bernie. I appreciate you, especially doing this while you're on vacation, and thank you, Heather, as well. And I guess I'm jealous of Bernie's location. I wish it sounds like a great trip. Just background, I'm the CEO of P6 Technologies. I'm probably best described as an entrepreneur. Some people say that because I'd otherwise be unemployed, but been launching software products for a long time, so 20 plus software products. Very passionate about sustainability. If you look across all the products, they've made some improvement to a supply chain, to eliminating waste, drive miles, sustainable solutions, including a weather platform, et cetera. Started P6 just at the end of 2022, starting in 2023, and we'll be walking you through what we're doing at P6. Let's go ahead and introduce Kira real quick. I'm gonna talk, and then she's gonna talk after me, but we'll go ahead and introduce her now.
Yeah, hey everyone, I'm Kira. I'm the Director of Product here at P6. I joined Joe a little over a year ago to help build this product, and we're really excited to talk to you about it today. Prior to that, I was working at Persephone, one of their first product hires across their carbon accounting software platform. I also worked with Joe at IBM on a variety of the sustainability-focused products that he already mentioned, and have a couple different degrees, but most of my background is focused on product development. Pass it back to you.
Thank you, Kira. Appreciate that. Okay, next slide. So I'm going to walk you through, just in this session, just some quick bullet points. We're hoping that you gain some insight into where companies are at on their LCA journey. We're going to go through a maturity model for that, understand the key drivers of LCA software adoption and what some of the challenges could be. Learn how to meet requirements from varying regulatory bodies, all supported with software, then with third-party verification. Discuss the challenges with the current approach based on where people are at. We're going to discuss and kind of infuse why we believe scenario planning is a critical part of the design, engineering, and improving existing sites and how important that is. And we believe not enough time is being spent on that. And then discover how to extract more value from LCAs through leveraging what we call an integrated enterprise solution. And then we get questions of how software can work with verifiers, and we'll talk through that as well. Next slide. So we actually generated this lifecycle assessment maturity model with Verdantix. I took it and adapted it for the biogas market. There's some specific things, and to normalize it to specifically where we're seeing RNG and biogas producers, where they're at today. It's broken into 5 levels. The first one is there's little to no LCA expertise internally inside the company. It's 100% consultant driven. They're generating the LCA. They control the spreadsheets, et cetera, to produce the LCA. The company has very little knowledge of kind of what's happening inside the 4 walls of a calculator. So they're dependent, and the consultants have actually played a critical role in this market. So that's level 1. Level 2 is companies, as they start to add more sites, they start to develop some in-house LCA expertise, either through a direct employee or the engineering team inside the company, or potentially a little bit of both. Third-party verification is still managed by third-party verifiers, so that process is critical, and you'll see that throughout all the stages. The verification doesn't go away. It's like a audit with accounting. You don't get rid of your auditors when you move to an accounting system like SAP or some other system, et cetera. So it's a critical process. A lot of manual data gathering and summarization, so to provide data to the consultants in level 2. The in-house team is starting to attempt to run scenarios. They're playing around with for example, LCFS Tier 1, Tier 2 calculators. They're complicated though. Over the GREET model, the base model has over 200,000 formulas in it. So don't feel bad if it's complicated, because it is complicated, even for the experts. So they're using Excel-based LCAs as the technology. Level 3, there's typically a dedicated team of LCA analysts and engineers. So they're now kind of full time on doing LCAs. Typically, as more sites are added, once you get to 5+ sites, sometimes less, you need a full-time LCA expert. Sometimes you need a team of people inside of it. Starting to get some automation though. So data gathering, semi-automated, but still lots of manual steps, but potentially some automated extracts or gathering from third-party farms to gather data, as an example, for dairy swine. LCA software could be used at this stage, but with manual data entry. So you're like the P6 solution can be used in this mode where you're keying in data into our screens, the inventory data per se inside of an LCA. Level 4 and 5 get more interesting. So you still have the dedicated team, but you're starting to expand the stakeholders. So more internal stakeholders are not active software users. They may be providing inventory data. They may be farms providing inventory data, potentially through software, as an example. So you're starting to expand the footprint of people who have visibility into the LCAs. You may start to pull in engineering as well to do a scenario analysis, or your third-party engineering firm to start to do scenario analysis. Integrated data happens at level 4. So you now have integrated data feeds and ingestion, data pre-processing, quality checks on the data, moderate analysis, and then automated reporting are happening at level 5, and then level 4. And then level 5, you're now starting to include finance and suppliers. So the people get expanded. So finance will get involved in forecasting, as an example. So taking the LCA data and historical data and generating forecasts from it, and then continuously doing that, which is critical. Right now, those two functions operate separately. And then potentially integrating suppliers. So you could be getting manure from different farms. It could be, as you start to get vertically integrated, as an example, there could be supply inputs that are provided for biomass, as an example, or bio waste. That waste can be coming from multiple suppliers, as an example, in the RNG space. Other spaces get more complex because the supply chain is more complex. But that being said, direct input from suppliers is critical. And then definitely integrated data ingestion, but then you're starting to use things like automation to continuously update the LCA. So think of an automated LCA where you can calculate it daily, weekly, monthly in a much more automated way. AI can and will play a role to identify opportunities or anomaly detection in this particular space, but you have much quicker LCA generation, and it's much more automated. And then if you kind of think beyond all this, where we have beyond LCA, you start to look at other things like water footprinting. So right now everything's carbon focused and carbon intensity, but there's other impact, land use, et cetera, start to enter the calculations for an LCA. So that's coming most likely in the future. Potentially electronically consuming LCAs, so the people you sell your biogas to can consume, almost like transactions happen in supply chain with EDI, electronic data interchange. So you have an electronic LCA gets sent across the supply chain, much further down the path. People haven't digitized their LCAs yet, but if you look at supply chain and other industries, that's the cycle it's gone. And then we're hoping electronic submission to regulatory bodies. So taxes followed this same pattern. So if you remember TurboTax back in the day, you used to print it out and mail it. And then now you can just click a button, and sometimes you get your return within days with solutions like that. So we're hoping for electronic submission. We have talked to regulatory bodies, they have not committed to that yet, but definitely seemed interested in potentially doing that sometime in the future. Next slide. Now, you guys know this more than anybody. The prior world was no regulatory requirements for both, it's actually fuels and biogas. It's becoming more complex. LCFS, Canada, Oregon, Washington, IRA, ISCC, RED 2, and they're now talking about RED 3. Varying calculators by gas type, voluntary, involuntary. And then there's others in process like Illinois, Hawaii, Michigan. Massachusetts, New Jersey, New York, and Vermont. So it's only going to get more complex. So this is what software is good at, is handling complexity. The goal is to load data once and then be able to generate all these regulatory-based LCAs as an output based upon that single input of data. Next slide. So what's the problem with the LCA approach today? It's kind of turn the corner. We're going to go into some details on the problem, and then I'm actually going to then hand it off to Kira to talk about how software can solve some of these problems. So the nice thing is that LCA is the agreed upon approach, but it needs to scale. So if you look at a lot of industries, they have a hard time even agreeing on the approach. So we're actually in a really good position from the positive side of things, and that everybody thinks an LCA is the right way to do it. Even the regulatory bodies are using LCAs. So score for the industry and for everybody involved. Some things that we believe need work. One is running more scenarios. That's where the real value is going to come to prior to the plant being built, but also after it's built to make improvements. There's very big variation. Sticking with my dairy swine examples, is -120 to -450 plus carbon intensity. That's a pretty big variability in how sites operate. So the same is true across renewable fuels and others as well. So not to pick on RNG as the example, I'm seeing it across chemicals as well. So no two products are the same. So what people have been using outdated software, the software that's in place is 10, 15 years old. It's PC based, so it's hard to use is the problem. A lot of spreadsheets, very complicated spreadsheets. The GREET model, as an example, is so complicated it can crash your computer. So you'll get a few chuckles out there from people who've had their computer crashed with the spreadsheet. On the other hand, it's impressive that they're running stochastic models inside of a spreadsheet. I was quite impressed that someone figured that out. That being said, it's not really the right place to run a stochastic model. Excel wasn't designed to do that. There's lack of support for regulatory LCAs and tools out there. And that's critical as people move forward with tax credits, whether it's a carrot or a stick. So the US is using a carrot, Europe is using the stick. That being said, LCAs are needed for regulatory purposes. What's missing is an enterprise platform to do an LCA. There's not the Salesforce.com for life cycle assessments. You need to do things like AI automation, security, auditability. So because it's regulatory data, it needs to be managed like an accounting system. So I spoke to one company and they lost their calculators from 2018 prior because the person left the company and they were on his or her PC. So you don't want to be in that position with not having the auditable information. You need it for 10 years. So I talked to a lot of engineering companies. They all say the exact same thing. Their customers are asking them to do CIs on their designs, but they don't do that is the answer. So they throw it over the wall to consultants. My view is, my pushback to them immediately is, if you're designing these sites, you should really understand the emissions and carbon intensity for it. Your customers are asking for it. You should understand how to do it. So software tools need to be more CAD tool-like and usable by engineers so they can run more scenarios versus throwing it over the wall. Right now, the customers are more sophisticated at running models than the engineering firms, and it's backwards. The engineers should be showing them how to design facilities and which feedstocks to use, et cetera. Lots of different models, you know that from all the different regulatory bodies. It's too time consuming is probably the number one complaint. 2 to 6 months to get an LCA done, let alone having time to run scenarios, which is where the value is. So there's consultants are just barely keeping up with the regulatory timelines. They haven't been able to run scenarios to make real improvements to the sites. So we need more of that. Obviously, this is just a sample of problems. You may have other problems. Scaling is one I hear as well, but this is a good starting point for you to think about. Next slide. So there's really 4 main types of biomass related that are the most common. There's certainly others as well, but dairy swine, as you guys know, well and good. Landfill gas, and then landfill gas to power generation as well. Wastewater, hopefully at some point in time, every wastewater facility has their methane captured. And then biomass is becoming more and more. Food companies, et cetera, are jumping in to produce RNG from their waste as well, and to find places to even put it, right? So right now, a lot of times it gets spread out, gets composted and then spread out on farms, et cetera, but it's still releasing gas into the air. Next slide. So are all LCAs for regulatory agencies? Is another question we commonly get. There's really 2 markets. There's the regulatory market and the voluntary market. It's probably half and half, because if you look at the coverage of regulatory agencies, it only covers certain parts of the country, and you can only ship gas so far, especially if it's sent into a pipeline, et cetera. You can do interconnections, et cetera, but there's limitations. So there's a huge voluntary market out there as well. So an LCA tool needs to be able to handle both of these. Now you also, a lot of companies have both, so they want to compare. So you need the ability to do apples to apples comparison. So you still may want to use a regulatory framework for voluntary sites just to compare, but you may also want specialized models for the voluntary markets as well. So that's the ability to kind of run the same data through multiple models to get to what you need. And one need may be comparative analysis, another need may be to run data for a voluntary market. Next slide. So I'm going to hand it off to Kira, who knows the ins and outs of the P6 software and can talk about the benefits of using software.
Thank you, Joe. All right, so why is using software so beneficial? Well, you only need to get the data loaded one time, so getting your inventory data into the software once, either through integrations, bulk import, and then you can apply the endless models like Joe was talking about for any variety of these fuel programs you're responding to, and then also quickly update and rerun those models as those standards change. Analytics in software can be more powerful. You can go deeper into the data, and you can also run more data inside software than you could in a standard spreadsheet. Instead of spending time gathering data every year, you can shift towards scenario planning and results analysis to improve site and product performance, which I know Joe is also talking about as a problem and something that needs more focus. And then we can generate forecasts in an automated way with software so that you're constantly getting them updated and you can review them as the data updates over time in real time with your sites. And then as your team and your projects get loaded into software, your team can scale as processes become easier to repeat, and LCAs, forecasts, and scenarios are built upon instead of being rebuilt each year. Next slide. So as you evolve with software in your processes and unlock more capacity to run scenarios, you'll likely focus on planning and scenarios for on-site generation of energy, to glean insights from your input data, to make decisions about different types of equipment to use, especially to optimize your inputs around your baseline projects and avoided emissions on the RNG side, and on how weather might play a role in your results compared to production or your impact results specifically. Go to the next slide. But the point we're really trying to drive here is that what is needed is much more than just the LCA. Biogas producers need the ability to do quite a lot more. You need to be able to collaborate across teams or companies, get deep into your analytics so you can make improvements on real data, integrate with your different data systems, automate process scenario results, eventually with AI or the application of various models on that same data. We're at a point where enterprise level software is truly needed to continue to optimize performance, receive credits, and reduce environmental impacts all at the same time. Go to the next slide. So as more of the processes are automated with software, verification will still be part of the automation journey too. In the near term, this will include automation of approval and workflow management in software systems, but we can't fully automate the review process yet until a documented methodology is put in place. We also don't expect yet to have the external verification process to change much, but it should evolve with technology to streamline those workflows. However, factors like your on-site site reviews for QA will definitely still be needed in the short term. Go to the next slide. So what could this software platform look like? We think it could look a lot like what we're doing here at P6. It's one of the reasons why we're talking to you today. It needs to be an enterprise platform with features for creating and completing LCAs, generating reports, forecasting, adding in scenarios, automation or analytics layers on top of all those features. But beyond features, it needs to include advanced data import options, so you only need to set everything up once to get your operational data into your projects. You can use APIs or bulk import to do that sort of thing. You could directly load it into screens. Really, software can do it however you want to within your processes today, wherever you're at, meet you where you are. You need enterprise level security and architecture in a software platform that's handling this type of data. You also need versioning, single sign-on, especially for larger enterprise companies. And you need a library for relevant impact datasets and properties that you can always access so that you can pull the right data into your models or review data in real time. The software platform should also allow customizable models so that it's easy to update models as different fuel programs change or as you want to run different scenarios with different data to see different projections. You need to have scalable process building. You need support for collaborative workflows and approvals. And lastly, you will benefit from templates tailored to your different products and fuel programs to speed up the LCA creation process. This is a lot, but software can handle a lot. And that's why P6 was started. And I think that's the last slide. So I'm going to stop here. We've thrown a lot at you. Love to open it up to Q&A.
We just have a couple questions in the chat, but I know everybody was listening. So if you guys haven't taken advantage of the question feature, please go in and do that now. Drop your questions for the P6 team. To start off, I'll go to the first question, which has P6 already engaged or utilized an AI ML group or expertise to leverage their domain knowledge in establishing a model?
So we actually have a background in AI in our team. So at IBM, the actual software unit was originally AI applications, then eventually became sustainability software. That being said, there's specializations in various models. We do expect to use, most people are familiar with large language models like Chat GPT. We'll most likely use a small language model that's highly specialized, so you don't get hallucination in models. With an LCA, you need exact answers and exact data, so you don't want a model hallucinating. There's all kinds of funny stories out there where people have gotten a free car from a car dealer, or a lawyer used ChatGPT to get some case data that was a hallucination. So they got in trouble with the courts. So you don't want that inside of your business. The other area we think is potentially anomaly detection. So think of that as finding things that are abnormal, right? And anomaly detection models are very, very good at that. And there's trained and untrained models. So we're exploring that as well. Data cleansing is an area where AI can actually help. So there's a lot of data that potentially needs to be cleansed or cleaned. And there's models for that. Obviously, we're already have forecasting in the works. So there's potential forecasting models, but statistical forecasting tends to be better for forecasting than most AI models. But unless the past is very much like the future, because you remember AI, it works on training. So statistical models tend to actually do better than AI models for forecasting most of the time, but there's always exceptions to that. So those are the main areas. So small language, SLMs instead of LLMs. There's actually one other area that You could use a ChatGPT style engine for regulatory to like search through the regulatory docs to make that easier as well. You can currently do that in the current platforms though as well. You can go to like Copilot and get some of the answers for that, and they give you the links as to where they got the information from. So always double check those to make sure the source is something valid if you're using one of those tools. But that's a great question.
Yeah, that's well over my understanding of AI and how it fits into these conversations. So thank you for that. I'm going to combine two of the questions here with a question about just scope. So on one of the slides, you guys had sort of the bellwethers, I guess, right? Maybe the landfill and the manure, et cetera. But there's some questions in here about where does food waste fit and where does beef cattle fit? And if not obvious, what are the steps or adaptations to get those to fit?
Yep, Kira, you want to handle that one?
Take that. Food waste would fall under organic waste, which is essentially the biomass segment that we had there. So we are building pathways for organic waste LCFS emissions right now. I believe that's what that would fall under. And then beef cattle would be the dairy or swine manure based RNG pathway, which we're also focusing right now on all the LCFS fuel programs.
Yeah, we get asked, of course, of other like chicken manures comes up if you can figure out what to do with the ammonia that's produced from it. But there's others that'll eventually, once all the dairy swine farms on the in the country wind up with a digester on it, then people will move under probably to those other manure types.
Another combo to cover a couple questions. Can you describe how NOx emissions are being handled?
NOx emissions being handled today. We are handling emissions exactly how the fuel programs require you to. So if you come to us with a model for a certain fuel program, we'll handle it exactly the way that they need you to for that. If you have a voluntary market LCA and you're just not sure how to handle that, we'd need to talk it through with you to figure that out. That's the short answer, but I would encourage whoever asked that question to reach out to us after the seminar or the webinar. We can talk about it more.
Because we knew a platform was needed, because we're also doing renewable fuels and chemicals, there's a model builder inside of our software. So you can build a model for anything. Think of things like water footprinting, human impact analysis. All those are in the scope of an LCA tool. But there's custom models, and we knew that the models, we would be chasing our tail. Seems like every time you look, there's another model. So we made our software configurable to be able to code those. And that's actually what, as the Biogas Council produces a model, we would use our own template builder and model builder to put that into our software quickly. We just did, like, for example, we just took the 40B SAF model that came out, and we had it in our software within a week of them releasing it. So it's pretty fast to get it into our software.
No, that's awesome. I think that mostly answers this other question, which is this is intended to be layered on top of a model. So the reference in the question is great, but essentially it's a layer on top of any existing program model that has already been established.
We replicate the model, so we have a mirror of the GREET model. So we're running the exact same calculations that are in the spreadsheets. We actually provide the ability to then download the LCFS spreadsheet if it's an LCFS LCA, and then it populates the data, and then it's running the calculations using the calculators models, but the numbers match up. The reason we have to mirror it is so you can run scenarios inside of our software. There's also voluntary models as well. In that case, we have a spreadsheet and report that you can download out of our software, and then you can see the model inside of our software as well. So it depends if you're doing a regulatory or voluntary LCA, and what the need for it is. Obviously heavily GREET based for this segment, because that's the trusted model in this particular space. So yeah.
Okay. There is a question here about, is there a free version of P6 software for higher ed or any academic research endeavors?
That's a good question. I like that one. We're about to launch a program for universities and higher education, so reach out. So that's the core. We haven't yet launched it, but we're close to launching it. I'd like to get that out there because part of our mission is to make it so anyone can do an LCA. And I actually took an LCA course a couple years ago at MIT and was very confused at first with some of the terminology. I think I'm relatively quick and can pick things up, but I was confused. So I was like, this has got to be easier to do going forward. So that's been part of our mission from day one.
All right. There's a lot of questions in here about things that are in or out of scope of an LCA. So I'm going to filter those out for the moment because I think we've sort of touched on foundational things like GREET are still sort of underlying what P6 is doing. But it sounds like there are opportunities to expand what I would consider a baseline model like GREET to include things that maybe are referenced in these questions. There's things like worker safety, there's questions about specific pieces of equipment like compressors. So can you guys just maybe clarify in aggregate the ability, assuming that something like GREET is the foundational decider of what's in and out of the scope of the LCA, P6 would allow a particular user to expand upon that to include additional things that may not be reflected there. Is that accurate?
Yeah, that's correct. You'd be able to, so if, for example, with equipment, certain types of equipment are included as options you can select between in different parts of the GREET model, depending on what pathway you're working on. You'd be able to switch between those as we extract parts of the pathways from the GREET model and build those templates. But you'd be able to add to them too. So our model builder will allow you to edit things. So if you wanted to add more to the list and associate emissions factors with different types of equipment, different inventory values, etc., you would be able to do that in our model. But yeah, the ones we've already built on our side that we've pre-built based on GREET would be exactly what GREET has. So you'd be able to switch between those equipment options there. And so we give you that baseline. That way we can make all of those baseline templates available to users, and then you can go ahead and build in your specific confidential additional choices to the models.
There's 18 impact categories that are the most commonly used. Human impact is one of those. So you could take and model in like worker safety as an impact factor if you wanted to. It's not very commonly done though. The LCAs have been mostly carbon. Some people are starting to do water footprinting, more in Europe than the US. But there's actually 18 categories. It spits out some pretty complicated numbers and models. So like if you look at, for example, off a utility, the sulfur coming out of it, the percent of people with cancer from that is like 0.003%, right? It's a small number. So a lot of people are trying to decide what do you do with those numbers for those other impact categories. So the focus has been on, it's really carbon equivalent, which is all the other emissions mapped into a carbon number.
And a couple questions here about alternative fuels and maybe non-fuel LCAs. So the first being alternatives like methanol that we're starting to see emerge, and maybe what the capabilities are for that. And then also with respect to non-fuel LCAs, with respect to maybe buildings or other activities that somebody might want to go through an LCA process for that maybe isn't directed by a fuel program.
Yeah, I can talk about that. We have in our template builder essentially a general model that you can use for voluntary markets. You would be able to build a template around that way. We are integrating data sets. We already have EcoInvent integrated into the platform. So you'll be able to pull process data from data sets such as EcoInvent. We're exploring others based on those that our customers are interested in. So really it's about making sure that the data set that either you already have licensed, you share your license with us, you get it integrated in, or we ultimately prioritize because we have customer mass building in that industry. It's making sure that data is there. And then you'd use our standard general LCA model and build a template that way. for any impact category. So it wouldn't just be climate change at that point, calculating carbon intensity. You could go do acidification, water use, human toxicity. All of those are becoming more popular and when we start talking to chemical industry, for example. So as we go into other markets outside of fuels, all of those features for voluntary markets will be either built or they already exist.
For the fuels, biogases, we're building templates that would accelerate. So some customers, if we don't have a template yet, a customer, usually it takes 1 to 3 weeks to build a new template. So we'll build that into the engagement, but we're cranking them out as quickly as we can. Like we produced SAF from ethanol. We have an ethanol template already, working on ammonia, green ammonia. Will be most of the fuels. We renewable diesel, there's a template for that as well. So if it's a fuel or gas, we want to provide that just out of the box in our software as quickly as we can. If not, we'll work with the first 1 or 2 customers to build it out. You could just build your own. So there's consultants who would use our software and they have custom models they don't want to share with externally. They can still own their model and keep that IP inside the 4 walls. Like obviously the Biogas Council is investing in a model. You can put that in our software and the Biogas Council can remain the owner of that IP. And you're just using our tool to run it.
Question about methane slippage. Would you consider methane slippage on the methodology? I think that, again, that's an underlying model question, but I'll toss it to you guys anyway.
I personally don't know a lot about methane slippage, so I would want to talk to that person instead of giving them an answer now on this call.
Sounds good.
It's if it's mathematically calculatable, it can be put into our model, right? So you just need to know the math to be able to do it. Now, if it's a regulatory LCA, if it's not currently in the calculator, it'd be a tier 2 exception application. So then they may or may not accept that. So the more people ask though in certain categories, the more likely it's going to get approved though. So if you team up as an industry, the Biogas Council works with the regulatory bodies, you'll see more change quicker, right, as a category.
Here's a good question about model maturity. So what would be a good first step to graduate from an Excel type level 2 model LCA inventories to a more sophisticated approach?
I think our software makes that easier. Like we modeled it after tax software or like TurboTax. If you started reading the tax code right now, you'd be done in 20 years and you would have wasted a good portion of your life. So you don't want to do that. So if you can take the tax code and put it inside software, you can do that with these models and the regulatory rules. So we make it easier to do. We're not completely abstracting you from the emissions factors. You can actually drill in and see them, but we break them down into the processes, the life cycle stages, so you can actually see them better. The formulas and the spreadsheets are all over the place, and you have to spend days studying them to really learn them. So we make it easier to visualize. So that comes with just good software design though, to make it easier to use. So we believe our software would help accelerate that. And like as you mentioned, we're trying to go after students. So you're talking about someone who doesn't know anything about an LCA when they start a course, most likely, being able to get quickly ramped up to learn how to use a tool. Right now, the learning curve is on other software tools is 6+ months, and that's just too long. It's just, there's no way to make it scale. So the industry doesn't have enough people who can run, and there's too many products on the planet that all need LCAs. So you've got a backlog. And even if you threw more people at it, it's still not going to catch up at the pace it's going.
And I think there's a similar question here from Jared talking about, the complexity of LCAs being a huge hurdle for most organizations. And, the question being, what resources can organizations lean on to gain better insights? And, speaking from the ABC side of the industry, it's something that even somebody like myself or ABC staff or others within the industry, we are struggling with the same hurdle you are, Jared. There's, to Joe's point, right? I mean, it takes a very long time to really dive into the background of these models, and leveraging simplicity where it exists, I think, is one path forward to moving organizations forward in the LTA space without necessarily taking on the burden that Joe just alluded to, right? Which is having that in-house expertise that takes 6 months, 12 months, et cetera, to really fully understand all of those assumptions and calculations that are built into the models, you know, that originated, like you said, in Argonne and elsewhere. But I think I will just add a yes and to Joe's prior response, which is, you know, people developing tools like P6 and others in the industry to help jump that hurdle without deploying, you know, an army of technical experts that know the ins and outs of Argonne GREET.
One of the things that we did is what we call the system diagram inside of our software. So it allows you to visualize all the inputs, the outputs, the waste processes, and that allows you to see the scope and boundary a lot better. Right now, it's easy to manipulate the scope and boundary to make the numbers look better or worse. So you're not able to compare apples to apples on measurement. So the system diagram allows you to very clearly see the system boundary visually. So that's one of the things that we put in. The regulatory LCAs don't actually have that. So when we did, like for example, a dairy, swine, or landfill gas LCA, we kind of drew the system diagram that people had never been able to see before. So it was enlightening for people to just visually see them. I could call it a block diagram, for example, but it's a breakdown of the emissions by input, output, life cycle stage, process, waste. So that'll definitely help. That helps bring the scope and boundary to life much more clearly.
We have a couple questions here regarding the RFS and RINs. So I'll aggregate them a little bit. So how does the LCA interface with the LCA for EPA's RIN pathway applications? And then there's a question which I think is simply answered no, but I'll let you guys take it anyway, which is, you know, does this actually spit out what I would consider RINs or RIN generation estimates?
Not yet. The answer is no. We're not generating the RINs. That's an easy answer. We're focused on just the LCA. So if someone needs an LCA, we can do that. And the RINs are not that complex to then generate, but that being said, we had to get in market with an LCA tool first. So we had to kind of crawl, walk, run.
Okay. Also some questions on interactions with international markets. So 2 questions. Can the software be used elsewhere outside of the US in terms of the databases included? And a comment about mutual recognition being considered critical framework, and has P6 begun to consider how their system could contribute to this challenge in the future?
Kira?
Yes, to the first question, you can use our platform to create LCAs to respond to field programs internationally. We would either we are going to build templates for other international field programs, but you will also be able to build your own. And then the data sets we're loading in, we're making sure we're thinking about and ensuring we include international impacts. The second question is around like we're thinking about maybe we're setting up the data so that it's compatible with integrating with different softwares or data systems. Is that the correct interpretation? Yes, we are thinking about that. Definitely, we know we can't necessarily, especially on the supplier side, it's not very easy to force your suppliers to start using these systems. Experienced that problem also at Persephone, exploring a similar topic. And so we are thinking about that too, and looking into the different bodies that are setting standards for that and making sure that we will comply.
Yeah, the unit conversion issue becomes interesting, the gallons and liters, et cetera. With emissions factor databases coming from various parts of the world, they have to be converted. from one to the other. So software's good at that, but it's you have to do that from the ground up when you launch the software. And date and time formats change, and our software will, it's not yet, but it will get translated into 9 languages. So it's built to be translatable. So that's in the path as well.
Fantastic. Question here sort of to that end about all of the different methods and models that are out there. You guys alluded to them on the slide at the outset. You got California LCFS, you now have other state LCFSs, RED 2, EPA RFS, Canada, you name it. Are all of these already in the version available in P6 software today? Like if somebody engages with P6 today, are all of those sort of baked in?
No, not yet. We currently have CARB LCFS fuel programs. It's extremely fast for us to replicate the LCFS template for other fuel programs given it's mostly just swapping emissions factors, or some of them include land use change and some of them do not. And so we are building those as we have customers who want them. So we do have some customers who want Washington, Oregon, and those are being built now. Canada as well, British Columbia as well. The newer ones, we have not run into need to build those yet, but should you want, I know New Mexico's going up this year. If you want that and you work with us, we could, I'm sure, build that very quickly. Beyond that, as Joe said, it takes us 1 to 3 weeks to build new templates. So once we have customer priority to build the others, we will. We're paying very close attention to the EPA regulation around 45Z, for example, and we'll definitely be building a template to help you with that, leveraging the GREET model for the different pathways. So we have a roadmap to address them all. But right now, we're primarily for this industry space focused on LCFS.
It sounds like it's user driven at this point, but as users come into the system, those models and templates are being built pretty rapidly.
Yes, exactly.
A question about availability of the referenced block diagrams, or what are considered boundary diagrams. Are those available anywhere for the public, or is it just those that are engaging with the P6 software?
Right now, just those who are engaging with the P6 software.
I've hopped around, so let me go back up to the top of our list here to see what else we could cover.
One area we plan to publish the rule set that we use for the diagram. So if you look at the ISO standard, it's not very specific. So one of the issues we ran into is for the same fuel program, 3 different consultants would draw the diagram 3 different ways. And then we got them together and they would argue about which is the right. And there was differences in interpretation of whether something's in the system boundary, not in the system boundary, as an example. Like energy from a third-party utility provider was drawn outside the system boundary, even though it's actually considered in scope for the system boundary. So we created a rule set. It's almost like we built the first CAD tool for LCA software. So whoever created the first CAD tool out there had to create the rules. And so we plan to publish those because we'd like to get those standardized. So you can talk across software tools and talk across companies and be talking about the same thing. It's kind of like self-inflicted confusion out there now because the standard wasn't specific enough.
Yeah, I think that was going to be my next question, which is the software allows for a lot of user-driven inputs and what I would say improvements in boundaries and scope and details that either a project or an industry has that maybe haven't trickled down into the policy or regulatory baseline models. And so the question I had is, to what extent are we narrowing that or bounding that in any way so that if somebody said, well, I used P6 software to generate my LCA, that means something different for user A versus user B based on the templates that they've worked to create with you guys and the scope of those boundaries. Do you guys feel like that's very fluid? Is that a risk in general for the amount of flexibility that this software offers? Or do you guys feel a consensus or a boundary that is a little bit more firm?
Well, if you want to compare apples to apples, then you have to use the same scope and boundary and emissions factors. So that's the that's the benefit of putting the data in the software once and then spitting out all the models. So if you did want to compare apples to apples, you could say, okay, we're going to use Canada as our basis, and we're then going to compare using the Canada model at 2 sites, right? Now, if you're comparing 2 different models with 2 different emissions factors, they're going to have like one may have grid electricity in scope, one may not, right? So you have to really know what you're comparing to know the differences. Now you can do that with diagrams like tornado charts, etc. as well. So we're doing that in our forecasting tool as an example to run like multiple LCA scenarios and then compare them. And they could be under different regulatory frameworks. So the tornado, or what people call a sensitivity chart, allows you to then see what's different between the two in the numbers from there. But you have to use the same model and scope and boundary if you want to do a fair comparison, right?
Yeah. So word to the wise, those engaging with these. P6 has some awesome capabilities, but you still have some boundary conditions that you need to be cognizant of as you guys enter your inputs into your comparisons. We're getting a little bit light on time, so I have one more question for you guys, and I have one that I'm going to address directly. So there's questions in here that I would consider less LCA, less software specific, around impacts of LCAs, around specific programs, longevity, like LCAs in the California LCFS, et cetera. For those of you on the webinar that have, I would say, more philosophical or policy-driven questions about LCA's role in policy or role in specific programs, please reach out to ABC. I'm happy to answer that from the policy side of things. We just don't have time or really intent to answer policy questions today here on the webinar, but I'm happy to help you through those answers offline. The last question for the P6 team is how many people are engaging with you guys right now? When you look at the software and its rollout and its growth, how many users do you have?
But for RNG, the plan is to have up to 60 sites live by the end of the year on it. So we launched for biogas in February. So we just recently launched the tool. So we're definitely newer into the market. We're still working on landfill gas and some of the others, but those are coming quickly as well. But the adoption has been pretty quick once we have the actual solution available. So, and
Fantastic.
we expect to continue to get that, through the end of the year and next year as well.
Yeah, we'll be ready to bring our 60 sites through their first fuel program submissions first half of next year.
Big milestone. Fantastic. I'm going to turn it back over to Caroline, I think, for any closing things. And I want to thank Joe and Kira and the rest of the team for supporting the webinar today. And those of you that joined, a lot of great questions. Thank you for engaging. It makes these highly valuable when you guys get your questions answered.
Thanks, Heather. And I want to second your thanks to the P6 Technologies team. Thank you again for sponsoring. Thank you, Heather, for moderating. Just a reminder that we do have a survey that pops up when we close out the webinar. Please answer that survey, and the recording will be sent to you within this week. Thank you all for joining. Have a great rest of your day.
Thank you, everybody.
Strong work, really strong work today. Thank you, everybody. Great job.